Hi guys, welcome to day 2, special right triangles. Today we're going to be tackling the 30, 60, 90 triangle. So yesterday we tackled a 45, 45, 90 triangle, and that came from a square. Today we're tackling a 30, 60, 90 triangle, and this triangle comes from another triangle. It actually comes from an equilateral triangle. All right, so vocab. What do we remember about equilateral triangles? Well, equa is equal, lateral is sides. So this is a triangle that has 3 equal sides. If you happen to remember another word that sounds very similar to that, equiangular triangle, an equilateral and an equiangular triangle are the same triangle, just describing different things. So not only is this equilateral, it's also equiangular, which means equal sides, equal angles. So it has 3 equal angles. Now, if this right triangle has 3 equal angles, how big is each angle? That would be 180 divided by 3. So each angle is 60 degrees. All right, so this guy is 60, this guy is 60, this guy is 60. Now I'm going to draw something in here called the altitude. So the altitude is the height of the triangle. So it's from the very tippy top all the way down to the base, the lowest part of our triangle. So from all the way here straight down, this is our altitude. Now, what is special about every height and every altitude is that it is perpendicular to the base. So when we get into finding area, that'll be really important. Your altitude and your base always have to be perpendicular. So if this is perpendicular, do you see that this one big triangle is now 2 small triangles? Don't forget that this angle is already 60, which means this angle has to be 90 because it's perpendicular. So how big is this guy then? 180 minus 90 minus 60, this has to be 30 degrees. Magic! 30, 60, 90 triangle is formed. All right, so what does that do for us? Well, in an equilateral triangle, do you remember equilateral means equal sides? All the sides are the same length. So if this side is 2, then this side would be 2, and this side would be 2. Okay, this is the hypotenuse of our small 30, 60, 90 triangle, right? Because it's across from the 90-degree angle. This side right here is a leg, and this side right here is a leg. So if you remember from yesterday's 45, 45, 90 triangle, when we had this square, right? And we did our triangle, we had 2 legs, and we called this like a leg and that's a leg. I don't want to call this leg and this leg because that means kind of like they're the same size, but do you see that those are clearly not the same size? So I'm going to think about this as our short leg because it's shorter, and I'm going to think about this as my long leg because it's longer. Okay, so here's another fun fact about your altitude. In an equilateral triangle, it will actually cut this in half. So that means if this whole thing is 2, this side is 1, and this side is 1, right? All right, pause the video, practice your Pythagorean theorem skills, and can you please find out how long or how tall this triangle is? Find the height. All right, so we're going to have 1 squared plus, I'm going to call it b, because that's a squared, b squared, c squared. We can think of it that way. 2 squared. So b squared equals, this would be 1 and this is 4, so we'll subtract 1 from both sides. B squared equals 3, so b equals a square root of 3. So that means this right here is a square root of 3. Now there's a lot going in this triangle, so we're going to pull it out for a second. And actually, we've already done this first part. I took this triangle right here. Do you see it's just kind of on its side? So this is still a 30, 60, 90 triangle. Even though this isn't marked, if that's already 30 and that's already 60, there's only 90 degrees left. So then if we do the Pythagorean theorem, like we just did up here, this side would be the square root of 3. Now, do you remember yesterday that 30, 60, 90 triangles are all similar? I'm sorry, 45, 45, 90 triangles are all similar because they all have the same angle measurements. Guess what's going to happen here? All right, before we jump into that though, let's look at this problem right here. We're just gonna use the Pythagorean theorem. We're gonna find this missing side. Ooh, this is gonna get tricky. B squared plus 6 root 3 squared equals 12 squared. Now, this is why I say it's tricky. If you forget to put parentheses around this, then you're only gonna square the root 3, but we need to square the whole side. So if you put this in your calculator, it's going to give you the wrong answer unless you put parentheses around it. Because what this means is 6 root 3 times 6 root 3. So do you remember we can multiply the roots together? Well, we can also multiply these numbers in front together. So this would give us 36 times root 9, because 3 times 3. So 36 times 3. Yeah. All right, so that's B. I've got all this work just to show you that. B squared plus, I don't know, 36 times 3, 108 equals 144. So I'm going to subtract 108 from 144. B squared equals 36, so B will equal 6. All right, so that means this side right here is 6. Now I want to show you what happens. Like, right, remember here we got 108 because we squared it, we multiplied by itself. In your calculator, if you might have a different calculator than me, but if you forget to put parentheses around the whole thing, so I have parentheses around the 3, but I don't have parentheses around the whole thing. When I square it, do you see that I only get 18 instead of 108? That's because my calculator is just doing square root of 3 times the square root of 3, which is 3, and multiplying it by 6 instead of also squaring the 6. So if I want to get the 108, I have to do a set of parentheses around the whole thing too. So you can see I have a set of parentheses around the 3, but I also have a set of parentheses around the whole thing before I square it. And that's how you can get your 108 from your calculator. All right, so now we got that figured out. Let's look at what we got over here. Do you notice anything between these? Well, a minute ago I whispered they're going to be similar, right? Which means they'd have the same scale factor, shouldn't they? Let's see if these do. So, scale factor. If I just use these two sides. Now, how do I know these two sides go together? They're corresponding because do you see how they're across from the same angle? They're both across from 30, so they're corresponding. So whenever you're doing scale factor, you have to make sure that you do the corresponding sides. So 6 divided by 1, that would be 6. So if our scale factor is 6, 1 times 6 is 6, 2 times 6 is 12, the square root of 3 times 6 is 6 square root of 3. So these are similar because they all have the same scale factor. That will be true no matter how big or how small your triangle is. So if that's true, then here we could do the same thing. If they're similar, if all of these are supposed to be similar, they should have the same scale factor. So let me compare my two sides. So I'm going to compare my two 30s. So my scale factor would be 3 over 1, so that's 3. So I'm going to times by 3. So 1 times 3 is 3. 2 times 3 would be 6. And the square root of 3 times 3 would be 3 root 3. All right, that's doable. Let's look at our next one. Now in this one, we know the hypotenuse this time. Remember how we said like short leg and long leg? This here would be my short leg, and we'll get into that on the second page a little bit more, but this I'm going to call my short leg because it's across from my small angle, and this is my long leg because it's across from my bigger angle. And this side will always be our hypotenuse because it's just always across from the 90-degree angle. So we know our hypotenuse, so we're going to compare it with our hypotenuse, which is 2. So our scale factor would be 8 over 2, so that's 4. So that means we're going to multiply everything by 4. If I go this way, so 1 times 4 gives me 4. Square root of 3 times 4 gives me 4 root 3, and 2 times 4 is 8. So we can find those sides just using similar triangles. All right, what do you see here? Well, this looks an awful lot like this one did, right? And if you look at your sides, we see we have 3 congruent sides. This whole big thing is equilateral. So when I draw in the height, I form a 30, 60, 90 triangle. So we want to find A and we want to find B. Well, we can do the same thing because this guy is still going to be similar to that because they still have the same angle measurements, 30, 60, 90, 30, 60, 90. So then what do we know? Well, we know the hypotenuse is 14, and that's 2, so our scale factor would be 14 divided by 2. So our scale factor is 7. So we're going to multiply everything by 7. So then what matches up with A? Which one of these sides matches up with A? What's its corresponding side? Well, A is across from 30, so it's going to match up with 1 because it's across from 30. So 1 times 7, A would be 7. B, well, we only have one side left, but B matches up with square root of 3 because 60 is across from B, and 60 is across from the square root of 3. So the square root of 3 times 7 is 7 square root of 3. So A was 7 and B is 7 root 3. So we can still use that similar triangle stuff to help us on these 30, 60, 90s. And you might like that and you might not. So let's talk about a second method. So our second method is our shortcut method, like we had the other day. So let's look at our general 30, 60, 90 triangle. This is for shortcuts. So for the shortcut. So first thing we need is some similar language. The longest side will always be the hypotenuse. So I'm going to label this H a lot of times so I don't have to write the whole word. These other two sides here are called legs, but clearly one of them is longer than the other one. So I'm going to call this one here short leg. Now I'm not calling it the short leg because it is vertical or it's on the left side. I'm calling it the short leg because it's across from 30. So our short leg is always across from the 30-degree angle. I'm going to label that a lot of times SL for short leg. This guy right here is going to be my long leg. And I'm not labeling it the long leg because it's the only one left. It's because it is across from the 60. So our long leg is always across from the 60-degree angle. So if I talk about my hypotenuse in the same kind of way, hypotenuse is always across from what? The 90-degree angle, or the right angle. Sorry about the dog. Mailman is here. Okay, so what can we do with these short leg, long leg, and hypotenuse sides then? Okay, so my short leg, I'm going to call it X. Let's go back here for a second and look for a pattern so we can fill out the rest of this triangle. Okay, so our short leg, our hypotenuse, and our long leg. Our short leg, our hypotenuse, and our long leg. Our short leg, our hypotenuse, and our long leg. I want you to take a minute. I'm going to finish labeling this. And I want you to see if you see any pattern in between these four, any relationship in between these four. Maybe you remember the pattern from when you were in school or when you're on online learning. Just take a second, pause the video. What do you notice? This is really important. What do you see? So our hypotenuse, do you see that it's 2 times bigger than our short leg in every single one of these problems? 1 times 2 is 2, 6 times 2 is 12, 3 times 2 is 6, 4 times 2 is 8. Even over here, A is our short leg because it's across from 30. 14 is our hypotenuse, 7 times 2 is 14. So that means between the short leg and the hypotenuse, it's always 2 times bigger. So this is 2 times bigger than the short leg. So if this guy is X, this would be 2 times X. All right, so that's our first pattern we've noticed. Let's look at our second pattern. Short leg to long leg, short leg to long leg, short leg to long leg. What do you see? Do you see that all of these, first of all, have a square root of 3 in them? And, I mean, technically, couldn't we put a 1 there? Isn't this short leg is 1, short leg root 3, short leg is 6, short leg root 3, short leg root 3, short leg root 3? So our long leg is always the short leg, so x, times the square root of 3. So if we have this pattern, if we memorize this pattern, we can use this instead of similar triangles, whichever one makes sense to you is what you should use. So kind of like, not kind of like, exactly the same as when we were doing 45, 45, 90 triangles. If we know a short side and we want it to get bigger, then you're going to multiply. So small to big, you're always going to multiply. So if you find your short leg first, then all you have to do is multiply to get to this side, right? And multiply to get to this side. So if I know my short leg and I'm going to hypotenuse, we would multiply by 2. If I know my short leg and I want to get to my long leg, I'd multiply by the square root of 3. Now, the reverse of that would be if you know a bigger side and you're going to your smaller side, you're going to divide. So if I know my hypotenuse and I'm going here, I'm going to divide by 2. If I know my long leg and I'm going to my short leg, I'm going to divide by square root of 3. Now you always want to go to the short leg first because then it can very easily find the missing side. You can go here, it's just more difficult. So I would suggest always do x first. Always find short leg first. Find short leg first. It will be very helpful. Not necessary, but very helpful and make this a lot easier or feel easier. All right. So let's look at example 1. I did not start out with a super basic one. We're going to put our thinking skills to the test here. So we know this is 5. First of all, we need to know which side it is. Is this the short leg, the long leg, or the hypotenuse? Well, the short leg is across from 30, so that would be this guy. So this is our short leg. Hypotenuse is across from 90, so we know the long leg. So if we wanted to find the short leg first, how do I go from here to here? Well, the long leg is bigger, so we're going to divide. So we're going to take 5, which is our long leg, and we're going to divide it by the square root of 3. So we're going to do 5 divided by the square root of 3. That is how you find your short leg, which means that's it. Your short leg is just 5 divided by square root of 3, nothing else. If you want to rationalize it, you can rationalize it if you know how, or you can send me an email and ask me about it, and I can send you a video about how to rationalize. But otherwise, that's your answer. All right, so if we know the short leg, then how do we find the hypotenuse? Well, the short leg is smaller, so we're going to multiply. So short leg to hypotenuse, we're going to multiply by, you guessed it, 2. So we're going to take our short leg and we're going to multiply it by 2. So in this case, that's 5 over root 3 times 2. Do you know how to multiply these? Make it a fraction, multiply straight across. So our hypotenuse is 10 over root 3. That's it. So short leg, 5 over root 3, hypotenuse, 10 over root 3. Okay. Some of these are going to be a little tricky to get your head around the first couple times, but with a little bit of practice, you'll become a pro. Let's look at what we got. First, let's label our sides. What is this side? Hypotenuse, short leg, long leg. Well, it's across from 30, so it is our short leg. So we need to find the hypotenuse and the long leg. Now, the good news is anytime you know your short leg, all you have to do is get bigger. So the only thing we have to do is multiply. So for our hypotenuse, we multiply by 2. So 8 root 2 times 2. That would be, now the 2 here, the second 2 is not under a square root, so you can only multiply it by the 8. So this will be 16 root 2. For our long leg, we're still getting bigger, so we're still going to multiply, but this time we're going to multiply by the square root of 3. So we have 8 root 2 times the square root of 3. This time, these two are both under square roots, so they can get multiplied. So that would be 8 root 6. All right, so this was our hypotenuse, this was our long leg. Moving on. I would love for you to try these two on your own, but if you're not feeling it quite yet, that's okay. But if you're feeling bold and you're feeling brave, pause the video, give it a try. All right, so first we're going to start out with labeling. This is our hypotenuse because it's across from 90. So we're going to find our short leg and our long leg. So if you remember up here, I suggest we find our short leg first. It just makes our life a lot easier. So we're going to find our short leg first. We're going to find this side first. Just going to redraw this picture here. So 30. So our short leg is x. Our long leg is x root 3, and our hypotenuse is 2x. Okay, so we know the hypotenuse, and we're going to the short leg. So we're getting smaller, so we're going to divide by 2. So 9 divided by 2 is 4.5, right? Okay, so that's our short leg. That's our short leg. Okay, now we need to find the long leg. Well, we know our short leg is 4.5, so this time we're getting bigger, so we're going to, bigger is multiply. So we're going to get bigger, we're going to multiply by the difference between these two here, which is that square root of 3. So 4.5 times the square root of 3. That's our long leg. So that's just 4.5 root 3. There you go, that's it. All right, last one. 10 root 3, which side is this? Short leg, long leg, hypotenuse. It's across from 30, so it's our short leg. We're looking for the hypotenuse and the long leg. It's awesome when you have the short leg. Your math is pretty easy. You just have to multiply. So for hypotenuse, we're going to multiply by 2. So our hypotenuse is going to be 10 root 3 times 2. So that would be 20 root 3. The 10 and the 2 get multiplied. Our long leg, short leg to long leg, so we're still getting bigger. We're still going to multiply. This time we're going to multiply by square root of 3. So 10 root 3 times square root of 3. So these two can get multiplied. So that would be 10 root 9. The square root of 9 is just 3, right? So this is really 10 times 3. So it's just 30. So our hypotenuse is 20 root 3, and our long leg is 30. Now, one thing that we haven't really talked about is like knowing if your answers make sense. Like our hypotenuse should be the longest side. This doesn't mean much to me. How do I know 20 root 3 is bigger than 30? That doesn't seem right. So let's check it out on our calculator by turning this one into a decimal and comparing it. So if I do 20 times the square root of 3, it's 34.6, which is bigger than 30. So even though this number looks like it's smaller than 30, its decimal is 34.6. It's actually bigger than our long leg. That's good, right? Our short leg should always be the smallest side. So 4.5 is smaller than 9 for sure. And 4.5 times the square root of 3 is 7.8. So that's definitely smaller than that one too. So it's really important to make sure that you know your hypotenuse is always your biggest side, your long leg's always the medium, and your short leg's always the small. So 16 root 2 is about 22.6, and 8 root 6 is 19.6. So that's clearly the biggest one. And then our short leg is 8 root 2. So this is about 11.3. So shortest leg is the smallest number, long leg is the middle number, hypotenuse is the biggest number. All right, if you guys have questions, this 30, 60, 90 triangle will take practice. That's okay, we're gonna get some more practice next time. Otherwise, please reach out, ask questions. That's what I'm here for. Have a great day.